everybody, welcome back to my channel. So today we're going to learn about terminating and recurring decimals. Now, okay, so what terminating decimals are? Basically the terminating decimals have a finite number of digits after their decimal point. Like for example, we have 0.625. Okay, so there's no digit after 5, so 5 is the final digit. Okay, so it stops, this decimal stops at 0.625, so it stops at 5. There's no number, no digit after that. Okay, so this is known as a terminating decimal. It can also be like, let's suppose we have 1.237. Okay, so there's no digit after 7, so the uh, fraction which we converted into a decimal, it stops at this digit 7. Okay, there's no remainder, even after there's no remainder after that. Okay, the remainder was 0, hence it stopped at this very last digit. Okay, there's no digit after it. Next, what is recurring decimal? Now recurring means repetition. All right, something repeats itself. Now they have an infinite number of digit pattern repetition after the decimal point. It means that 0.16666, so there's a fraction or a digit, like let's suppose we have 1 upon 6, but when we express it as a decimal, what we have is, we have this 0.16666, and this digit 6 repeats itself again and again and again and again, so there's no stopping over it. Okay, so this is known as recurring decimal. Recurring decimal can also be like, let's say 0.125252525. So the pattern 25 is repeating itself again and again, so it's a recurring decimal. Okay, and there are infinite number of digits after that. It doesn't stop at any point, so it's till infinity, right? Okay, so how we're going to express a recurring decimal? So we have a dot notation for it. Okay, so what is basically the dot notation? Because we write a dot over the decimals that are repeating itself. Let's suppose in this case we have 0.16, right? The 6 is repeating itself, so we write a dot over the 6. It means that it is repeating itself. All right, so basically 0.16666 can be written as 0.16. Okay, now let's suppose we have a fraction 0.1 sorry, 1 upon 3, which is written as 0.3333333, and so on. It can also be written as 0 point, since 3 is repeating itself, we're going to write 3 once and put a dot over it, so it means that recurring. Let's suppose we have a number 124 upon 999. Now in this case, what we are left with is 124, 124, 124, and so on. So the pattern so the digit 124 is repeating itself in a pattern, so it can be written as 0.124. Since 124, all the three digits are repeating, so we're going to write it as 124, and we're going to write dots on these digits. Okay, and let's suppose we have another fraction. Let's write it over here. 7 upon 11, right? So when we divide 7 by 11, we are left with 0.636363 and so on. And in order to write it as in a dot notation, we're going to write it as 0.63, and we're going to write the dots over 6 and 3. Okay, so this is what dot notation for recurring decimals is. This is how you're going to write the recurring decimals. In terminating decimals, there is no repetition of the decimal. They stop at one point and they don't have any remainder. But in this case, when you divide, let's suppose we divide 1 upon 3, right? So we divide 3 by 1 by 3. So what we get, we have to put a point, right? We can put a 0, and it's like 3 threes are 9, sorry, 3 threes are 9, so 1. Again we're going to write, and 3 threes are 9, 1, then again 0, right? So it goes on and on and on and on. Okay, convert each of these fractions to a decimal. Now we have first fraction 3 upon 8. So how are we going to convert this fraction? it is equal to 3 upon 8 is basically equal to 3 divided by 8, right? So we're going to divide 3 by 8. So what are we going to get? 3 upon 8 is equal to, we're going to divide, we're going to put 3 inside and 8 outside. So we're going to put 0 and a point, and we're going to put a 0 here. So how many, what is the closest? 230. You know that 8 twos are 16, 8 threes are 24, 8 fours are 32, right? So we cannot go with 4. So because 8 fours are 32, we have to go before. So 8 threes are 24, right? So when we subtract, we get 6. We can also have another 0 here, because with the point, you know that you can have zeros easily. Okay, so how many times? 60. We know that 8 6 are 8 5s are 40, 8 6 are 48, and 8 sevens are 56. 8 sevens are 56. We have 4 here, and we're going to put another 0, and we know that 8 fives are 40. Okay, so the answer stops at 5. So 3.8 is equal to 0.375. Okay, now we have 5 upon 16. So 5 upon 16 is equal to 5 divided by 16. Now 5 upon 16 can be expressed as 16 outside, 5 inside, so 0.0. Okay, how many times 16 is 50? Okay, 16 ones are 16, 16 twos are 32, and 16 threes are 48. So 48 is the nearest to 50. If we go 16 by 4, it will be increase. So we're going to write 3 here, and it is 48. Now after subtracting, we will be left with 2, and we're going to put 0, and then again we're going to put 1, and we're going to write 16. So after subtracting, we will be getting 4, and then again 0. Okay, so here 40. So the closest is 16 twos are 32, and then we have left with 8, because when 10 minus 2 is 8, and when we put 0, so 16 fives are is 80. Okay, so 5 upon 16 is equal to 0.3125. Okay, now let's move to the next one, which is 79 upon 250. 79 upon 250 is equal to 79 divided by 250. Now what will be the answer of 79 upon 250? We're going to divide. So we're going to divide 79 by 250. Alright, so we're going to first write the point and have a 0 here. Okay, so which is the nearest? You know that 250 ones are 250, 250 twos are is 500, and 253s are 750, and 254s are 1000. So the nearest is 253s are 750. Alright, so 0 here, and we have 4, and we can have another 0. So the nearest one to 400 will be 251s are 250, 252s are 500, which is greater than 4. So we're going to write 251s are 250. Okay, so what we're going to do? 3, this will be 1. Okay, 0 minus 0, 0. 10 minus 5, 5. And 3 minus 2 is 1, 150. We're going to write another 0. And we know that 254s are 1000, 255s are 1250, and 256 are 1500. Alright, so what are we left with? 0.316. Okay. Alright, now let's have a look at another example. Convert each of these fractions to a recurring decimal. Write your answers using dot notation. Now, They have already told this from the question that these fractions will be having a recurring um, decimals as an answer. So what we're going to write? We're going to write them as using a dot notation. So first we have is 2 upon 3. So 2 upon 3 is equal to 2 divided by 3. So what answer we will be getting is, when we divide 2 by 3, right? So it's like 0 0.2, 0 0.6 is 18. Then we're left with 2, again 0, 6, 18, 2, 0, 6, 18, and so on. So what we'll be having is 0 0.6666, so on. So in case of writing the answer using dot notation, we're going to write 0 0.6 and we're going to write a dot over the 6, which shows that it reoccurs. All right, so it repeats itself. Now the next one is 4 upon 15. Okay. Now for 4 upon 15, it means that 4 divided by 15. Okay, so 4 upon 15, which is equal to 4 is inside, 15 is outside. Now 0 0.0. So 15 ones are 15, 15 twos are 30, and 15 threes are 45. So we are going to write the nearest one, which is 2, 30. 0 and 10. Again 0. So we know that 15 twos are 30, 15 threes are 45, 15 fours are 60, 15 fives are 75, and 15 6 are 90. All right, so the nearest one is 15 6, which is 90. Okay, so again, what are we left with? 0 and 1, so it will be 0 and 1. Okay, again 0, so it means that 6, again 90, then again we are left with 10, and so on. So it will be 0 0.2666 and so on. So how are we going to write 4 upon 15? It will be 0 0.26 and a dot upon over 6, because 6 is repeating itself, not 2. Okay, now let's have a look at the next one, which is 16 upon 33, which is equal to 16 is divided by 33. Okay, so how are we going to express 16 upon 33? 16 is inside, 33 is outside. Now 0 0.160. Okay, now how many times 33 is near to 160? Okay, 33 ones are 33, 33 twos are 66, 33 threes are 99, and then when it comes to 33 fours are, it is 132. Okay, and when you add 33 again, like 33 into 5, it increases. The value is more than 160, right? So we're going to stop at 4 and we're going to write it as 132. Now we're going to subtract. We have 5 here and 10, so it's going to be 828. All right. Now again we have to put a 0 and then we have to find out what is the nearest to 33. So the nearest would be 33 into 8, which is 264. Okay, this is 7 and this is 4, like it's 16, and 7 minus 6 is 6. Again, the pattern is repeating. 4, 132 gives us 28, and then 0, again 8, 264, and we are left with 16, and so on. So the pattern that is 4848. So it goes like 0 0.48, 48, and so on. So what are we going to write it as? 16 upon 33 is equal to 0 0.48, and we're going to write the dots on 4 and 8 because both of them are repeating themselves. Okay, now let's have a look at this example, at this question. Now we have been given a recurring decimal and we have to convert it into a fraction. So how are we supposed to do that? We have been given that 0 0.1 dot is equal to 1 upon 9. Write each of these as a fraction. Now we have been given 0 0.2 and 0 0.5 recurring decimals. So how are we going to express, and what is the purpose of giving this 0 0.1, this condition like 0 0.1 is equal to 1 upon 9? So how we're going to do it is that We know that 0.1 is equal to 1 upon 9. So 0.2 dot can also be written as 2 into 0.1 dot, because when 2 multiplies by 0 it is 0, dot comes as it is, and then when we multiply 2 to the 1 we get 2 dot. Alright, so and we know that 0.1 is equal to 1 upon 9, so we can also write it as 1 upon 9 instead of 0.1. So we're going to write the fraction 1 upon 9. So since 2 and 9 are not divisible by each other, we're going to write 2 upon 9. So 0.2 recurring decimal is equal to 2 upon 9. Let's have a look at another example. 0.5. Now 0.5 dot can also be written as, can also expressed as 5 into 0.1 dot, right? When 5 is multiplied by 0.1, it gives out 5 zeros are 0 dot, 5 ones are 5. So it gives out 0.5. Now, instead of 0.1, we can also write 1 upon 9. Okay, so it can also be written as 0.5 dot, can also be written as 5 upon 9. Okay, let's have a look at another example. I hope it will help you to understand it better. We have 0.3 dot. Okay, now what are you going to do in this case? 0.3 dot can also be written as 3 into 0.1 dot. Now we can write 1 upon 9 instead. Now here you can see that 3 and 9 are divisible by each other, so 3 ones are 3 threes are. So 0.3 dot can also be written as 1 upon 3. Okay. Alright, now let's have a look at another question. Given that 1 upon 27 is equal to 0.037 and 1 upon 11 is equal to 0.9, these both are recurring decimals. Find the decimal equivalent of 2 upon 27, 10 upon 27, 2 upon 11 and 6 upon 11. Now this is very much similar to the one that we solved before, but the condition has been reversed. First we were given the decimal and we were supposed to find out the fraction. Now we are giving the fraction. Now we have to find out the their corresponding decimals. So how we're going to do that? The condition is pretty same. Now we have to express 2 upon 27 into a multiple of 1 upon 27. We have to first look at the denominator, because the denominator here should be the same for this. Okay, so we have the denominator 27, we have to look for the 27 denominator. So how are we going to write it? So in this case, we're going to write 2, we are going to express 2 upon 27. 2 upon 27 is equal to, here you can see that we have 2. If we take out 2, the numerator common, we will be left with 1 upon 27, because the numerator multiplies with the numerator. Okay, so 2 upon 27 can also be written as 2 into 1 upon 27. Okay, so what we can write 0.037 instead of 1 upon 27, so which will be equal to 2 into 0.037, right? Which can also be written as, when 2 is multiplied by 7 we get 14, so we get 4, and when 2 is multiplied by 3 it gives 6, but we have one from one carry from 14, so it will become 7, and when 2 is multiplied by 0 it will give 0, and then 0 multiplied by 0. So when we multiply 2 with 0.037, we will be left with 0.074, which is the value of 2.2 upon 27. Okay, now again we have been given 10 upon 27. It can also be expressed as 10 into 1 upon 27, and when we multiply 10 with the corresponding digit, which is 0.037, what are we left with? Whenever we multiply a decimal related, like a number with the 0, like 10, 100 to 1000. So when we multiply, the decimal shifts further. Okay, so the decimal moves forward. All right, because when we multiply, the number becomes bigger. When we divide, it becomes smaller. So the when we divide, the decimal moves towards the left side, and when we multiply, it moves towards this side. Okay, so when we multiply, so 10 upon 27 will be equal to 0 point. Now the repetition pattern is after the decimal. So when this decimal moves towards this point. Okay, so when this 0 comes here, there's no need to write the repetition pattern, because the repetition pattern is after the decimal, right? So the 3 comes as it is, and then 7. Now in this case, now 3 and 7 are going to repeat themselves. So we're going to write 3, the dots open over 3 and 7, right? Now let's move towards the next number, which is 2 upon 11. Now in this case, 2 upon 11. Now 2 upon 11 can also be expressed as 2 into 1 upon 11. Now instead of 1 upon 11, we can write as 2 into 0.09, right? And when we multiply 2 with 0.09, it will be like, when we multiply it with 9, because we started from the extreme right. So when 2 multiplies with 9, it becomes 18. All right, so we'll be like 2 nines are 18. We will write 8, and then 1 is carry. When 2 multiplied by 0 is 0, and we add the carry on, which is 1, and then multiply by 0. So in this case, 0.18 will repeat itself, because 0.9 is 0.9 is multiplied by 2, so hence these two digits will repeat themselves again and again. Okay, so 2 upon 11 will be written as 0.18. Same case with 6 upon 11. 6 upon 11 can also be expressed as 6 into 1 upon 11. So when 6 is multiplied by 0.09, 6 upon 11 will be, since it's 6 is multiplied by the 9, this whole two digits 9, okay, 09. So the pattern will be like this: 0.54, 54, and so on. So we're going to write 54, the dots upon 54, because the 54 is going to take place for 9. If it was let's suppose 1, 0.01, it will be written as 0.06 and dot dot dot. All right, so 6 upon 11 can also be expressed as 0.54, 54, 54, and 0.54, 0.54 with the recurring dots over it. Okay, so I hope you understand this very clearly. If you have any difficulty, do let me know in the comment section down below. And if you have any difficulty in a topic, just write it down in the comment section. I will definitely get back to you, or make a video on a topic related to maths. Okay, it is not necessary that it is from the topics that I've covered. You can also tell me the topics on which you need more information, you need me to explain to you. Okay, so I hope you understand my today's lesson. So meet you in my next video. Till then, take care and bye bye.